All right, hi everybody. It occurred to me today throughout class that there were a lot of questions about the word problems and when do particular modeling formulas apply. So I thought it might be helpful to make a short video about what the keywords are that you're looking for in word problems that kind of tips you off as to which modeling formula you should use. So first and foremost, if you see anything having to do with the word compounding, compounding interest, for example, compounding, that keyword usually means you should be using this formula here, where A is the amount of money that you start with in your account, R would stand for the interest rate, N is the number of times you're compounding per year. That shows up in two places, and T is time in years. Now the key here, and the reason I said it's usually used when you're compounding, if you're compounding, let's say, semi-annually, N is 2. If you're compounding quarterly, N is 4. And if you're compounding, let's say, monthly, N is 12. All right, you get the idea. When you compound continuously, that's not this formula. That's the formula on page 24, and I'll address that. But when you have a finite number of times per year that you're compounding, semi-annually, quarterly, monthly, maybe even daily, where N is 365. If you see that word compounding and then a discrete number of times that you do that in a year, this is the formula. Okay, now to decide between these two, let's say you're working with a word problem that does not have the word compounding in it. To decide between these two, if you see any words like doubling, tripling, or halving, right? So for example, the population doubles every 6 months, or the value of your car triples every year, or half-life, right? The amount of an element gets cut in half over the course of X number of years. These would be examples where you would want to use y equals a times b to the x, where b in this case would be 2, b would be 3, or b would be a half, all right? Now here, notice that these have r in them, all right? And r, you're looking for the word rate. So if you see anything about a growth rate, 1 plus r, or a rate of decay or depreciation, 1 minus r, this is typically the formula you're going to use, all right? Where r is your rate of growth or decay, but you want to make sure that you're converting the percentage to a decimal. So for example, let's say they give you 6.3%. You want to make sure you're converting that to 0.63 before you're plugging it into the formula for r. Okay, so those are those three formulas. And now again, for these formulas, the word you're looking for, compounding, followed up by a discrete amount of time. These keywords would be doubling, tripling, halving. And then here, the keyword would be looking for rate. All right, so what happens if you don't have those things? Or what happens if you're seeing the word continuously? So that would be looking at this formula here at the bottom of page 24. If you see anything about continuously, continuous growth, continuous decay, continuously increasing, continuously decreasing, that is the tip-off that you need to use a formula that involves the natural base E. And E is this number, it's approximately 2.72. This formula, A, is the amount that you start with, so maybe it's the initial number of people in your population. We could have continuous growth of that population modeled by base E, raised to the power of R, that would be your rate of growth or your rate of decay, multiplied by time, all right? So the tip-off for when to use this formula is called continuously, right? So you're looking for that word continuous or continuously in your word problem.